some previous year questions from the chapter metal forming. Now you can see that this is a question from grade 2014. Now this is a match the following question. In group A they have mentioned defect in extrusion, rolling and the products of skew rolling and rolling through cluster mill. And in group B they have also given some data. So we'll start from group A P. They are saying defect in extrusion. So now in group B the first thing is they have mentioned is alligatoring. No, alligatoring is not a defect of extrusion, it is a defect of rolling. It's a rolling defect. It is basically it is basically a defect in which the edge breaks down. Now the second option is scab. Scab is again not a extrusion defect, it's a casting defect. Now the third option is fishtail. Yes, fishtail is an extrusion defect. So what is basically fishtail? Fishtail, it is due to the movement of surface oxide and impurities towards the center of the billet. So for P it's 3. Now defect in rolling, as I have already mentioned that alligatoring is a rolling defect, and in this defect the edge breaks down and it is because of non-uniform deformation. So for Q it's 2. Now the product of skew rolling. Screw rolling is a process which is used to manufacture balls of ball bearing. So for if you see in group B, so it is 6. See, it is clearly mentioned that semi-finished balls of the ball bearing. So for R it's 6. Now what they are saying in S is product of rolling through cluster mill. So if we again look at the options, we find that the only option left is of 4 and 5 and 2. 2 is basically casting defect, so it's already eliminated. Now we have to choose between 4 and 5. Cluster mill is basically a combination of backing rows and working rows in a rolling method. So in this method the working roll is a very small dia, so this is basically used to make thin sheet. So for S this is 5, thin sheet with tight tolerance. So now looking at the options, we see that option B is correct. Now we can solve it through elimination method also, as I have already told you in the previous video. So now we will start using elimination method. Now in group A, as I know that skew rolling is a method which is used to make balls of ball bearing. So for R it is 6. For R it is 6. So now we can eliminate options C and D by looking at the options. It could be either A or B. Now you can see that S is 5. So S is 5 is also fixed. So these two are now eliminated from group B. Now we know defect in extrusion or defect in rolling, the question will automatically get solved. Let us assume I know that the defect is of rolling. You might be knowing defect in extrusion or you might be knowing both of them, so it doesn't matter. So for defect in rolling, as I have already told that alligatoring is a defect due to rolling. So for Q it's 1. So now we will look at the options, we see that option A gets eliminated. So the correct answer is option B. So we can use elimination technique in examination type of environment so that we can save our time in an examination like GATE. Now moving to the next question. So again we can see that this is a GATE question from 2014. Now in this question what they have mentioned, that a mild steel plate has to be rolled in one pass. See, this is a one pass arrangement, such that a plate final thickness is in 2/3 of the initial. It says 2/3 of initial thickness. So let's say initial thickness is Ti. So Tf will be 2/3 of Ti. Now what they're saying, that the entrance speed of 10 meter per minute. So they are saying that let's say Vi is the entrance speed, be 10 meter per minute. They have also mentioned the dia of roll. So let's say dia of roll is 500 mm. Now what they are saying that the plate widens by 2% during rolling. So let us say that initial width is wi, so the final width will be 1.0 times 1.02 times of wi. Now they are asking what is vf, that too is meter per minute. Now so you can see that most of the data are in terms of initial data, like t final is in terms of t initial, w final is also in terms of w initial. So the only data they have given is of v initial. So when now applying conservation of mass, since no mass addition is taking place in this question, therefore rho a into v initial area initial is equal to rho area final into velocity final. Now the density of the metal is not changing, so rho initial and rho final is same. Now area initial, what is area initial is wi into ti, and what is the velocity initial, that is 10 meter per minute. Area final is w final into thickness final, tf into velocity final, it is vf. Now we'll put all the values, we will get w initial into thickness initial into 10 equals to, what is w final, it is 1.02 times of w initial. What is thickness final, 2/3 of thickness initial into velocity final, w initial t initial gets eliminated. Now final velocity, which we will get it as 30 by 2.04, which is equal to 14.7058 meter per minute. That's the answer. Now moving to the next question. In this question they are mentioned about a rolling process. In a rolling process, the maximum possible draft, what is the maximum possible draft, they have also defined that it is defined as the difference between the initial and the final thickness of the metal sheet. And they are asking that it depends on which parameter. So we know that delta h maximum is denoted by a formula which is equals to mu times r in rolling, where mu is coefficient of friction and r is roll radius. So now looking at the option, we say that it's strain, no it doesn't depend on strain. Strength of work material, no it doesn't depend on strength of the work material. Roll diameter, or we can say roll radius, yes it depends on this. Roll velocity, no it doesn't depend on roll velocity. Coefficient of friction between roll and work, yes it depends on coefficient of friction between roll and work. So it depends on r and t. Now looking at the options, we see that option b is correct, so that is the answer. Now moving to the next question. Again this is a question from rolling operation, and in this question they have already mentioned that the maximum thickness reduction is given by delta h max equal to mu times r, mu square r. So they have given delta h max equals to mu square r, where they have also said that r is the radius of the roll, mu is the coefficient of friction between the roll and the sheet. They have said that mu is equals to 0.1 here. Now they are asking the maximum angle subtended by the deformation zone at the center of the roll, and the angle which they have asked is in degrees. So one formula is already given here. The other formula which we can derive in a roll pass arrangement, suppose this is a roll and this is a metal which is coming out, I'm only drawing the half portion. It is basically symmetrical in nature. So let us assume that this is the angle alpha. Sorry, I have made a mistake while drawing. It won't start from here. It would be from like this. It's like this. So let us say that this is the initial thickness of half initial thickness, and this is the half final thickness. As I have already mentioned that this is axis of symmetry, and I have drawn only half portion. So let us say this is alpha. Now if this is radius of rho, so from trigonometry we can say that this is, let's say, O, A, B, and this is C. OC is equals to R cos alpha, okay, and OB is equals to R, okay. And now what they have asked is basically BC is equals to what, and BC is basically, you can see from the figure that it is TI minus TF by 2. And what is TI minus TF? TI minus TF is basically delta H maximum by 2. So it is can be written as BC can be written as OB minus of OC, which in turn can be written as R times 1 minus cos alpha, which in turn can be written as delta H max equals to 2R 1 minus cos alpha. Now say this is relation 1 and this is relation 2. Comparing from 1 and 2, we get mu square R equals to 2R into 1 minus cos alpha. R and R gets eliminated. Cos alpha becomes 1 minus mu square by 2, which will be becoming, putting all the values of that is of mu, we get cos alpha is equals to 0.995, where alpha will be 5.73 degrees, and they have asked in degrees only, so that is the answer. Now moving to the next question. So this is a question from wire drawing operation. It is a two-stage wire drawing operation. So what the question says is the fractional reduction. And what is the fractional reduction? That is a ratio of change in cross-sectional area to initial cross-sectional area. So they are saying that fractional reduction, let's say I am denoting it by R. What is that? Is delta A by A initial. So delta A is A initial minus A final by A initial. Let it I say that it is in 1, 2, 3 terms. So A1 minus of A2 divided by A1, which can also written as 1 minus A2 by A1. Now in the first stage, what they are saying that R1 is 0.4, okay. The fractional reduction in second stage, for second stage let's say R2 is 0.3. so what is 0.4? 0.4 is equal 1 minus A2 by A1. So A2 by A1 becomes 0.6. Similarly 0.3 equals 1 minus A3 by A2, which that implies A3 by A2 becomes 0.7. Now what they are asking is overall fractional reduction. R equals A1 minus of A3 divided by A1 is equals to what? So it can be written as R1 minus A3 by A1, which can be further written as 1 minus A3 by A2 into A2 by A1, Now from, so let's say this be first and second, from first and second, and substituting this value into this equation, we get 1 minus a3 by a2 as zero point 0.7, a2 by a1 as 0.6. If we get 1 minus of 0.42, which is equals to 0.58. So this is the answer. Option B is correct. Now going to the next question. So this is again a question from rolling operation. So we can see that rolling is a very important topic when it comes to GATE examination. Already 3 questions have been asked from GATE 2014 to 2015 only, from the same topic, rolling, and most of the questions are from the same formula, that is delta H maximum is equal to mu square R. So I would suggest that you practice more and more questions based on this concept. Now coming back to question, it is saying the roll is of dia 500 meters. So please keep in mind that they have clearly mentioned that this is dia. So dia is 500 mm. So what would be the radius? It would be 250 mm. So that's why I always say that write all the data. It will help you in making less mistakes. Now what they are saying, that the initial thickness is 25 mm, and they are saying that it cannot be reduced to less than 20 mm in one pass. So this is also one important data, one pass. So what they are saying, that delta H maximum, which is denoted by T initial minus T final, is 25 minus 20, which is 5 mm. Now using this relation, we will get the value of friction, since they have asked the coefficient of friction only. So 5 equals to mu square into radius, that is 250. Solving, we will get mu as 0.1414. So this is the answer. Now going to the next question. So in this question they have mentioned that a 300 mm thick slab is being cold rolled. Again this is a question of rolling, and the roll is of diameter 600 mm. So our initial thickness they have said it as 300 mm. Now what they have mentioned, the dia of roll. So dia of roll as 600 mm. I am converting it into radius of roll, which is 300 mm. They have also mentioned the coefficient of friction, that is 0.08. They have mentioned mu equals to 0.08. Now what they have asked, the maximum possible reduction. See, this question is again based on the same formula, which is delta H max equals to mu square R. Substituting all the values of mu and R as 0.08 whole square into 300, we get the values as 1.92 mm. So this is the answer. Now moving to the next question. So this is a question from GATE 2016. What is the question? The question says the value of true strain produced in compressing a cylinder to half its original length. So we know that true strain is denoted by ln L final by L initial. Okay, so now they have mentioned that L final is equals to L initial by 2. They have mentioned half its original length. Now putting the value, we will get L final is L initial by 2 divided by L initial, which becomes minus ln of 2, which is equals to minus 0.69. So the correct answer is option B. Option B. Now moving to the next question. So in this question it is saying that it is desired to make a product having T-shaped cross section from a rectangular aluminium block. Which one of the following process is expected to provide the highest strength of the product? So see, one thing they have mentioned is that is an aluminium block. Aluminium is a material which is very difficult to weld as well as cast. So I won't say that it can't be welded or it can't be cast, but the next thing which they have mentioned is about the strength. So this two method doesn't provide aluminium that much strength, so these two options get eliminated. Now we know that metal forming is the only method which provides a superior strength as compared to all the other metal forming techniques. So the right answer for this question is metal forming, because they have asked the highest strength. Highest strength will be provided by metal forming only. So the correct answer is option C.